So today we are going to do a bit of demo around the flight tracking. And essentially, we want to introduce you to the event-enabled APIs with Event Mesh. So the demo will be conducted and the talk will be conducted by myself. My name is Vidya, and I'm joined with Tazeef. So both of us we work with Solace and we take care of solution consulting for Solace in the APJ region. So what I want to do is essentially I will set the stage for this demo. So the main agenda is we want to walk through some of the main concepts about event-driven architecture and event enabling your APIs. So I'm sure if you have seen or watched Tom Fairbairn, who just some time back talked about event products and how do we or what is Solace vision about productizing the event APIs. You might have got some understanding about where Solace wants to take the event enabled APIs. Okay, so to set the stage, I mean, essentially, if you look at the evolution of IT back from, let's take a recap of last 20 years. So we started with things like go-to function and procedures, RPC. So typically we have always been request reply. Our way of dealing or doing the processing has always been if I want to do something, I will call a function, the function will do the thing, and I will get my response back. So we have been doing that, and that is how the evolution has been for long time. But if we think from take example of capital markets industry, so they figured out or they have been operating differently right from mid 90s. They have been always talking about asynchronous event driven way. I mean, when the capital markets or equity markets trading floor were digitized, it was all asynchronous. They could not afford to do everything in a synchronous way. So why event driven is very important? Consider, I mean, our normal day-to-day life, we respond to events, we never poll things, right? When an alarm goes on, we just switch off the alarm. We don't keep on waiting for the alarm to trigger on. So there are events all around us, and there are events which needs to be acted upon. So example of the events are the customer feedback or OT update, employee onboarding. So all these events occur and they have a value in time. So if we look at the value of our data, when that event occurs and how do we respond to that event really determines the value of that data. So if you, I mean, this is the sort of Gartner's view about the need for speed. So as the event occurs on the x-axis, you will see the real timeness of the event or the value of the event in terms of being real time, in terms of seconds, minutes, or hours. How do you respond to that event and the data value? So the sooner you respond to an event, the more valuable it is. So for example, predictive maintenance or predictive analysis. Take example of a credit card fraud detection mechanism. You want to be able to detect a fraud when the transaction is happening. You don't want to detect the fraud has happened after, let's say, few minutes or hours. So that is the value of events, and that is where that is where you need to essentially, as an architect, as a developer, you need to be watching out for these events and act on the events. So from the digital value chain perspective, I mean, events are occurring in our daily lives, within the organization, within the enterprise. So how do we basically respond to those events? So essentially, you either respond to an event by either polling whether the event has occurred or not, and that is the typical way the API gateways or API function or service mesh are built around. So the fundamental is REST. REST inherently is very request response, very chatty kind of thing. So that is one way of implementing your API strategy or implementing the solution architecture for the business problem. The other way, like capital markets did long back, is you want to essentially be an observer for the event, register an interest for the event to occur, and then just move on. In the sense, you don't have to keep on continuously waiting for the event to occur. You just register an interest and move on. When the event occurs, you will be notified. So that is the very high level overview of how event driven architectures are implemented and how event driven systems react to events or operate on events, right? So what we are uh, saying is, it's not a debate about whether it is event versus API. It is the concept where we talk about event driven API. So event driven APIs are essentially a new style of API that uses a subscription or push model. So people who are used to very RESTful kind of API paradigm or RESTful kind of API solutioning, they always think from the request reply perspective. And the event driven API or event enabled API, you need to switch or you need to flip thinking a little bit by registering an interest and then acting once the event occurs. So it's typically like, and this is not something very new. If you think from the classical design patterns perspective, like, there is an observer and observable pattern, and that pattern essentially is the same. I mean, it's basically the it's the thing that you register an interest for, and that observable changes and observer gets notified. So if we have to just compare between open API and async API or event driven APIs, so open API is the definition or the de facto standard for uh, describing your API. So it's a language independent, language neutral specification that the code generators can ingest and then generate the API that can generate the actual client implementation. So similarly, async API, what open API is to REST APIs, async API is to event driven APIs. So the fundamental difference between the two is open API typically work on a request response fashion, whereas the async API or EDA works on event. Uh, Open APIs are typically one-to-one, and the examples of why I say one-to-one is because there is a requester and there is one responder. So a request goes to a service and then the service respond back, and it's very chatty kind of mechanism. So some of the examples where open API or the RESTful API makes sense is like transactional systems, transferring of the funds, getting a balance, booking a ride, where you want to make a transaction and you want to get an acknowledgement. That is where the RESTful APIs make sense, where the user need immediate response. But then there are a lot of use cases where there are like there are parallel processing required to an event that has occurred because of the RESTful invocation. So that is where the async API comes into picture. So typically async API would be like a broadcast. So an event occurs, you want to notify to one or many consumers or the subscribers of that event. That is one to many broadcast kind of pattern. And the examples are notifications and price updates, marketing offers, location updates. So these kind of things. Now, if we look at where is the merging or the amalgamation of API and event occurs, so think from that perspective. On the most left side, the REST API and service mesh. So there is no eventing happening. So everything is very synchronous, request reply, and stage by stage or step by step. So typically how we would write our procedural programs, right? Function A calling function B, calling function C. So everything is in sequence. So the total round trip time for your invocations or for your transaction is essentially the summation of all the steps that you have to take. Now, what event driven methodology says is not necessarily everything should be in sequence. So if you decompose your business problem, you will see that there are some things that needs to be executed in sequence, whereas there are other things which can be done in parallel. So that is where the REST API, that is the middle swim lane, where REST API is used for your north-south traffic, that is the vertical traffic, and the events are used for east-west. But in this case, you will observe that RESTful APIs are synchronous request reply, whereas the events are only ingesting, they are not responding back. So that is where REST and async API meet together. That is the third swim lane, where your microservices or your components, the async API components, can subscribe to event, operate on the event, and also generate event out for the other consumers or subscribers to listen into. So to make it more concrete, let's take this example, an order management event flow. So let's say you go on an online shopping website and you buy something. So doesn't matter what product you are buying. Essentially, it's a combination of, or essentially it's a series of steps that needs to be executed. For example, first you need to validate an order, then you need to do a check, a credit check or some kind of check where whether you have sufficient funds or not. Then you need to do inventory check, payment processing, order processing, and on top of that you may want to do bit of cross sell upsell. You will have big data lakes for doing the batch analytics. You might have some AI and ML engines for doing the insights. Now all these components, if you see, there are few things which needs to be absolutely executed in sequence and few things that can be parallelized. So synchronous fast path is where you will do order validation, credit check, inventory check, payment processor, so process a payment, and then immediately respond to the user saying that the order has been accepted and you will get the delivery on so and so date. The rest of the things, the order, the actual processing of the order, the shipping, the cross sell upsell activities can be done in parallel later. So if we go back to our previous swim lanes, this is where our problem or that uh, solution can be decomposed. So this is our synchronous request reply path, and the other path is essentially all parallel. So north south events going on synchronous fast path, and east west asynchronous parallel path does the eventual consistency and default execution. So what I'll do is I'll take a pause here and I'll hand it over to Tazeef to get into the actual demo. So in the demo, we will be showing you how these events are propagated and how the event product is used. So Tazeef, over to you. I will just stop sharing my screen.
Sure. Thanks, Vidya. Hi, everyone. My name is Tazeef. I'm a sales engineer based out of here in Mumbai. Uh, Thank you for joining. So let me share my screen. Is my screen not visible?
Yes.
Okay. So how do I expose my existing APIs as event-driven APIs? Okay. So here's a problem that we are looking to solve. The problem is in this demo, what we'll be doing is we'll try to track the flights on a real-time basis over the Indian subcontinent, Indian airspace, and for which we'll be getting the data from Open Sky network. Now, a simple way how things are currently done are being done is we have different brokers in different environments which where they're currently getting all the real-time traffic from Open Sky, and it differs from geographical location to geographical location, but everyone gets all the data. With the way how we will address this is via event mesh. So what we will do here is we have created a mesh and we have deployed a broker across each of different cloud service provider. One is on AWS, one is on Azure, and one is on GCP. So we have deployed one instance of broker here in Mumbai, Another broker is deployed in Singapore, and the third instance has been deployed in Hong Kong. And we have our own Java application that we have created, which will be basically interacting with the OpenSky network and Amadeus. OpenSky network will be used to track all the flights, and for validating the data, or as a reference data, will be referencing the data from Amadeus system. The communication between the Java application and these two OpenSky network as well as Amadeus will be done via Sync REST API. The rest everything will be managed via DMR. Now let me jump into the demo to get more clarity. Okay, so this is our demo. Now, once when the demo starts, let me zoom out. Sorry, yeah. Once when I start my demo, we should start seeing all the flights over here in this specific area. So we have restricted it to only Indian airspace. Now, before I start the demo, so there, as I mentioned, there are three clouds or three instances of Solace broker to which we will be connecting. As you can see over here, one is based out of Hong Kong, and this is the URL to connect to that broker. If I click on refresh, this is the second instance, which is based out of Mumbai, and the third instance, which is based out of Singapore. So for my demo purpose, we'll be connecting to an instance which is based out of Hong Kong. Now, once I've selected my broker, the next thing what I will do is I will connect to this specific broker. And this is the topic on which we'll be subscribing, wherein we can get the data for all the flights that are currently being tracked, or the data has been shared over India. So let me subscribe. I should have a start feed coming up any moment now. Here it is. Now, something to note that this sky feed, what we'll be getting will be for 10 minutes. After 10 minutes, we'll have to redo this. I mean, that's the way how the program has been designed to avoid overloading. So these are all the aircraft that are currently flying over Indian airspace. Okay, this data is currently coming from OpenSky network. Now, and this is on this specific topic. So this is the data that is currently being propagated. So basically, the flight number, the latitude and longitude of for the location of every flight. If I click on a specific aircraft, let's say this specific flight that I have clicked on, the one that got highlighted in the black. If I click on lookup airline, this is where my connection will go to Amadeus and it will get the reference data. So if my memory serves me correct, this should be a Qatar Airways. Oh, here we go. For all the participants online and all aviation enthusiasts, we are using ICAO airline codes and not IATA. So Qatar Airways on IATA is QR, but on ICAO it is QTR. So that would be one difference. And all the participants online, if you would wish to, you can join in on our demo. You can use your mobile phone to scan the QR code. As soon as you do that, let me just show it to you. Vidya, can you scan the QR code?
Yep.
So when you scan the QR code, what essentially you will see is a new link, the new page that opens up. It's a static page, and it will basically give you this, what currently is seen highlighted on the screen, Qatar Airways. So if I click on any other aircraft, and if I do a lookup airline, this should be Air India. So the reference data is being printed on the new page that opens up. This should be Vistara. And this should be Go Air. Okay, now how does the mesh work? So as you see, currently I'm connected to Hong Kong broker. Let's say, let me change my broker, and I'm doing this on the fly. So I click on refresh, and now it has selected Mumbai broker. So click on connect and subscribe. Instantly, I get to see all the data. So My broker is basically I can divert any traffic that is coming from OpenSky network to any of the broker that has been configured in my event mesh. Or the technical term to use for it would be DMR, that is dynamic message routing. The benefit what you get with an event mesh or a broker is you get to have good scalability, and you will only replicate the data once, not all the time. So there are three brokers currently in a mesh that have been configured, but the data is being received from OpenSky or Amadeus on only one broker. Internally, the broker is replicating the data to the other two brokers as part of the mesh, and only on that broker which is currently connected on this dashboard. So the OpenSky data might be coming on Hong Kong, but on my screen, I'm consuming the data from Mumbai. So for the other brokers, there's no egress that is currently happening, or no consumers over there, so the data would not be traveling to the other remaining location.
So Tazeef, there are a couple of questions, and I would like to interject here and address them. So the first question is, how about securing the huge chunk of events and replay capability? So the security is embedded or inbuilt in the broker. So whether it is API or whether it is uh, the management perspective, the broker is highly secure. From the TLS perspective, authentication perspective, auth, everything is supported. All the leading security constructs are supported by the broker. And second thing is replay is available. So there's a huge you can go up to 6 TB of spool of data that you can replay. So that's pretty significant. And the third and most important thing is, what is DMR? So as Tazeef mentioned, DMR stands for dynamic message routing. And Tazeef, if you can bring up the screen where we show the brokers. So DMR is essentially a network of brokers that we connect together, and they form an intelligent mesh. Think of it, if we not talk about DMR, if we just talk about a single broker, it's an event driven broker, right? So the primary paradigm here is publish subscribe. So one broker, there may be one or more clients connected to it, and they will either emit events, and then there will be a lot of other clients, um, and there may be a lot of other clients which are interested in that event. So now, your clients can be connected anywhere in the mesh. The mesh takes care of propagating the information based on the topics, from where the event is generated to where it is consumed. So let's say, as Tazeef is showing on the map, Tazeef, if we can zoom it a bit. So let's say an event is generated in Singapore, and there is a consumer or a interested subscriber for this event in India. Then the mesh will automatically propagate that event from Singapore to India in real time in a most WAN optimized fashion in a secured way by itself. If there is nobody interested for that event in India, the data will not even travel over that WAN link from Singapore to India. So that is a very important construct where it helps you optimize the WAN. You are not sending data here and there unnecessarily. You are sending the data, the mesh is sending the data only where it needs to go. So from the scalability perspective, also this helps because it helps you to shard your event space in a horizontal fashion. So there's this following question from Jay saying, for high scalability purpose, how can we do that? So DMR offers you the scalability in terms of the adding more nodes to your mesh, and that is how you will be able to scale horizontally. The vertical scalability is very easy by adding more compute and infra resources to the broker and scale it vertically. So sorry, Tazeef, yeah, you can take it forward.
Yeah, thanks, Vidya. Okay, so this is basically the mesh map. As we both, me and Vidya, we have shared earlier that we have configured three brokers in a mesh in the APAC region. So these are the three locations on which the broker has been configured. Initially, I connected the OpenSky this thing application on my Hong Kong terminal. Later on, when I switched the connection, it was connected to another instance, which is Mumbai. So as of now, I'm connected from Mumbai location. So let me further make some changes and subscribe. Yeah. So now this broker is basically getting all the feed, and it is propagating data to the other two brokers, whoever has a consumers. Now, one thing, and Vidya has already covered this point briefly. So one thing, what additionally you can do is you can have multiple consumers here in Mumbai who are consuming the same set of data, or they can filter the data. Now, filtering in this case will be done. Okay, this has completed. So let me. So how does filtering happen in case of Solace? So we won't be filtering the data basis the content of the data. In this case, what I shall do is I shall filter the data basis the topic. So right now, what you see right now on the screen is only Vistara flights. Okay, so I had a complete list of topic, and using wildcard, I have subscribed to only aircraft flying on India, which are by this thing ICO code as VT. VT basically stands for Vistara over here. So no other aircraft currently is visible, only Vistara. So this is I'm doing it on the fly, on the runtime. I'm doing my application is getting data for can be requesting data for all, but via topic filtering, I can only showcase the data, or I can only subscribe for a selective subset of the data, actual data. Okay, so that's all I had in terms of the demo. I'll now move on to the second part of the demo that we have, or rather to say, we have already discussed this, is the event mesh. So this is basically on the cloud console that, sorry for this. So on the cloud console, when the Solace cloud console, when you log in, so this is your welcome screen. This is the home screen that you see. There are multiple things that you will be able to perform as task over here. The first is for streaming or creating a mesh. In order to do so, the first thing that you do is create a go into the cluster manager and create a service broker instance, followed by the mesh manager, which we just saw over here. The mesh that we have created for this demo. Yep. This is the mesh that we have created. And the next part of this demo is how do you manage the events that are currently propagating for this specific requirement or for this specific use case that we have created. So this is basically, we call it as event portal. And in these are the three applications that are currently that have been deployed. This is for the airline lookup microservice, and this is the OpenSky feed service. So the OpenSky network data, what we are getting is basically coming from here. And the Apidays application for which we are doing a reference data mapping is coming from this microservice. This big green dot that you see is our dashboard, basically my browser, which is able to get the data. And this dark green dots that you see, these are all the events that are currently flowing. So when I started my application, it basically sent a request to send the data, and finally, whatever data was available, the application sent out to us on our dashboard. After which, if I request for an airline lookup specific reference data, it travels on this specific service. Now, if I click on the applications over here, so these are the applications that we just discussed. And over here, I can get into the details of events. And so when you create events, basically you attach topic address to them. So these are the topic addresses that were attached, and we were basically tracking this topic. So flight code, flight track slash plane slash update slash source basically where they're getting the data and into the flight code. And then we further attach the filtering into the flight code. Instead of getting all the data, I was interested in only Vistara or an Air India flight. So I can put AI or VT followed by a wildcard. Now Solace basically uses wildcard as star and greater than sign. If I'm interested in all the data, I can have a greater than sign, and anything followed by flight track, all the data will be consumed by a specific consumer, or in this case, my consumer. If I want to have further granular granular filtering, I can use greater than or star sign, which I used in case of this demo. Vidya, want to add anything more to this?
Yeah, so basically, I will just from the product perspective, like Solace provides a complete platform, right? So you have a design time and runtime. So runtime is essentially a broker which connects together to form a event mesh, which we saw. So the runtime is the component which will help route the events which are generated by the event producers to event consumer. Doesn't matter whether the consumer is connected on that same broker or whether it is connected to a broker which is forming a part of mesh. So that is the runtime aspect of the broker. The design time aspect of the event platform or event architecture is this event portal. So event portal is essentially a platform for designers, developers, architects, data architects, business analysts to collaborate on building the event-driven ecosystem for building the event-driven applications. So if we look at the event portal, so Tazeef, if you go back to the actual event portal model in graph view, so you will see that there are solid green dots, and then there are those bigger application, bigger circles. So those circles are your microservices. Those are either microservices or they could be your integration flows that you build either in MuleSoft or TIBCO, BusinessWorks, things like that. Anything that is either producing or consuming an event is represented by that circle. The solid green dot is actual event, and the arrows connecting to them shows the path of the events, how the events are flowing. Now, why do you need that? Why do you need event portal? So if you are building event driven application and your application consists of only handful of microservices, let's say 4 or 5 services, 10, 15 events, it's okay if you don't use event portal. You could use something like Excel sheet or Confluence page to document all of that. But as soon as your application landscape increases, you have handful or you have a bunch of microservices, let's say tens or hundreds of integration flows, hundreds of events, then it becomes very difficult for you to one reuse the event because you don't know what you have. Then in that case, if you want something, you will most probably try and recreate it. So that kind of adds a technical debt. The second thing is change management. So if you want to change something, let's say if I want to add a mandatory value in my schema, I should be confident that if I'm making this change, who all I'm going to impact. So with event portal, I know because my schema is associated with an event or number of other events. So when I'm making a change to a schema on event portal catalog, so Tazeef, if we go to catalog, we can, yeah, maybe on schema. So when we select a schema, we get to know what all events are using this schema, and when we click on an event, we get to know what all applications are either producing this event or consuming this event. So event portal gives you a nice way of doing a change management and nice way of identifying if I make a change, what all is going to be impacted. So that's like, I always think event portal as like Google of your event driven application development landscape. Okay. The third and most important thing about event portal is you can actually build and monetize your event driven APIs. So like you have API gateway where you publish your APIs to your partners and establish a contract. So similarly, using this event portal products, you will be able to expose an event as an API. So Tazeef, if you go to the catalog again, we have a list of events in this domain. So we have close to 6 events, and we want to ensure. So let it come. No, maybe go in the application domain itself.
Yes, I'll do that.
So in the application domain, let's say if we have 6 events, and you will see that some of the events are private and some events are public. So event portal gives you to encapsulate the events that are private versus public. So if you'll see, there is only one event, a flight tracker update, which is public. Because what we want to do is, let's say if I have built this application and I want to expose this application as an API to my business partners, I don't want to give them the internals that is encapsulated. What I want to expose is actually the capability for them to subscribe to my event, so that they can be notified when the planes are moving around. So that thing we can expose by product. So see that only one event is shared, which is yes. So if we go to event products, so in event product, I can create a new event product. And if you click on flight tracker, so that's the event product which we will expose. And you will see there is one event that I selected for subscription. So this event product is now exposed on the website. So if I click on that website URL, it will establish the contract, or it will show me the contract for consuming this event API. So, there will be description about what is this product about. So it's a flight tracker, a little bit of description about it. Then the channel. So channel is essentially a term used by Async API specification. It actually translates to the actual topic that this event will be published on or subscribed from. And then it gives the details about the payload. How do I uh, parse the data once I subscribe to, or once I get the event. So that's a nice way of so event portal gives you that nice capability of managing the events and application and relationships among them, and also gives you the capability to expose the events for to outside world. So yeah, so maybe Tazeef, do you want to
Yeah, I'll do that.
talk about the actual URL and
Yes.
show
So
the subscriptions?
let me start this thing because it has stopped transfer only 10 minutes. So methods. Vidya, can you start this application till the time I walk through this thing, the new consumer?
Yep.
Okay, yeah, okay, it started.
Yeah.
Okay, so here is we left. Let me collapse this all. So now what I'm going to do is, if I click on server, so as Vidya was mentioning that we in this specific use case, there is only one event that we are exposing to the outside world. So on the fly, as the flights are being propagated right now for next 10 minutes, we'll add a new consumer. Now this new consumer is going to be over MQTT. So what I've done here is, if you so I have, if you can see my screen, I have a new client over here, the MQTT FX, and I have already configured the broker. Okay. So if I click, go to the network settings, this is the broker. So what I'm doing is I'm connecting to the Mumbai location. Okay. I have configured my connections and I'll connect over here. Now, as soon as I connect, it will ask me for subscription. So over here, my subscription is flight track / plane / update / star. In case of MQTT, the star basically will work as a plus sign. So right now, I am subscribing to all the topics that are currently being propagated on the maps. I can probably make a change over here, and I can add Vistara. Okay, so this is all the data that I'm getting right now. Stop all scroll. Yeah. So if I click on any one of the message, the same data that we were able to see on our demo on the page over here behind, I am able to see on my MQTT FX client. So this is a new client that I have added, which was not connected previously. So it can start getting, and it basically is getting the data. I mean, the event information from the event API tool, which we have decided that we only this set of event can be exposed to the external world or to some new client. So I have connected, and on the fly, on a dynamic, I'm able to consume the data from this about flights from our use case. Yeah, Vidya,
Yep.
that's all from my side.
Yep. Perfect. So I think we are almost towards the end of the demo as well as presentation, and taking the look at time. Also, we have like maybe 5 minutes remaining. So there's one question about rate limiting and SLA for consumers of the event product. So I was about to reply that in chat window, but I'll now talk about it. So essentially, the broker has got massive, capacity in terms of throughput and performance. So we don't need to really throttle the client. We are able to feed the client at the rate at which they can accept the events. So rate throttling is not done on the broker end or at the API provider end. It is generally on the client side. So when the client has consumed one event and when it is ready for getting the next event, then only we will send that event to the client. So from that perspective, it is perfect. The second thing is, let's say if the client is let's say if the client specifically wants that I want the event subscription, for example, in this flight demo, if the client want to get the update about the flight position only after 5 seconds, for example, so we have certain configuration within the broker by which we can uh, address that kind of requirement. So let's say if the client I want flight update only after 5 seconds or at a frequency of 5 seconds, we will be able to deliver only after 5 seconds, only to that client. But let's say if the other client wanted all the events in real time, we will do both. So in the sense, to one consumer who want all events, we will give all events. To other consumer which want event after every 5 second, after every 5 second window, we will do that also. So there is a concept called rate eliding. So using that eliding feature, we can do that. So if I have to sort of conclude this whole discussion and demo, a couple of key takeaways that I want to highlight is, uh, don't when you are thinking about APIs, don't just think about RESTful, synchronous, request reply API. Typically I have seen the architects coming from non-capital market background tend to think a lot about request reply. I mean, solving the problem using request reply paradigm, but that's not the only one paradigm. Think about event driven way, because the world is very much event driven. So that's pretty much about it. I guess thanks for joining and thanks for listening us. And yeah, bye bye.
Thanks everyone. Have a nice day. Take care.